Hello Year 11, welcome to Revision Week 9. This week we are going to try and cover quite a lot. We're going to cover three things: network performance, the difference between MAC and IP addresses, and the difference between the internet and the World Wide Web. To start with, can you make sure you have this revision sheet 7, in front of you ready to go? When you do, continue on with the video. Okay, first part, network performance. How well the network performs and transmits data and things. So have a look at these two networks quickly, okay? In this network, network A has faster performance than network B. Why? Well, look at the difference between the two. Network A has less people, yes, users on it. It also has fiber optic cables, and it doesn't use wireless. Network B has lots more different computers connected to it. It also has older cables like copper cables. It has wireless that could slow it down with data traveling through walls and things. So there are differences between these two. So there are different things to think about that affect the performance of a network. The first one that I want you to know is bandwidth, the amount of data that can be carried through a network at one time. The bigger the bandwidth, the more data that can be transmitted in one go. Think of it like pipes transporting water. The bigger the pipe, the more water, the bigger the bandwidth, the more data that can be carried. Remember, bandwidth is shared for all the users on the network. So if people are doing things like streaming videos or playing games, it can slow down the network if there isn't enough bandwidth. Second one, number of users. Very simple. The more users there are on the network, the more resources, the more bandwidth that's going to be taken up. The less users, the less bandwidth is taken up. Latency, sometimes known as lag. Basically, it's the delay between when the data is sent and when it's received. The bigger the lag or the higher the latency, the worse it is. The lower the latency, the better it is because there's less of a delay. Error rate. Sometimes data is sent on the network, but it might go missing or have a collision and things, and the data needs to be resent. The more errors there are, the worse the performance is because data has to keep being resent. The media, the actual hardware itself that's being used to transmit the data on, is it wired or wireless? Remember, wired is generally faster than wireless, but even with wired connections, depends if they're using copper cables, which are older and smaller bandwidth, or are they using more modern cables like Ethernet and fiber optic, which have a larger bandwidth and transmit faster. The hardware that's being used, is it new hardware? Is it reliable? Is it switch rather than a hub or a router and things? The hardware, if it's not designed or it's old, it can slow the network down. The choice of hardware. And the topology, the layout of the network. Are they using a star? Are they using a mesh? Remember, different topologies can be faster than others, can affect the performance too. So very simply, we've got the number of users, we've got the bandwidth, the media that's being used, the latency or delay, error rates, hardware, and the topology. These are all things that affect the performance of a network. Make your notes on this section here and then check your answers on the next slide. Okay, ready? Let's check. So we've got the number of devices. The more devices there are, more users there are, the more data that's being sent, and the more bandwidth that is used. Bandwidth, the amount of data that can be sent, the bigger the bandwidth, the faster data can be sent. Traffic, how much data is being sent on the network. Remember, if they're doing things like streaming video, that can be slow it down. The latency, the delay, and the number of errors, the more collisions that occur, the worse it is. Checking your answers, improving if needed, and then we'll continue. Okay, part 2. Difference between MAC addresses and IP addresses. So, remember, MAC addresses. Where is a MAC address used? When you're sending data on a LAN, on a local area network, we have MAC addresses. Each device has a network interface card that connects it to the network, and each network interface card has a MAC address. And that MAC address is unique to that computer. Okay? It belongs a unique MAC address that's connected to the network interface card, and it's unique to that computer. So a MAC address is a unique address identifier, so a device can be found on a network. Think of it like a house number and a postcode that lets you send a post to your house. The MAC addresses are assigned to the network interface card and you cannot change it. Once it's given to you by the network card, you cannot change it. They are normally 48-bit numbers, but when they're written out, they're stored as hexadecimal, so 12 digits in hexadecimal. And it looks like this at the bottom of the page. So remember, the MAC address is linked to the network card. Make your notes up at the top section now. So remember, MAC addresses are unique addresses used to identify devices on a LAN, a local area network. They are unique. They are linked to the NIC. They cannot be changed. And they are used by the switch to direct the frames of data on the network. And they are stored as 12 hex digit numbers. Okay, 12 hexadecimal digit number. MAC addresses. So what's different about IP addresses? Well, IP addresses are used when you're transmitting data on a WAN, such as the internet, a wide area network. Because there are so many more devices and things like that, well, IP addresses are used so data can be sent from one computer across a network. And we're going to look at this more next in a later video. IP addresses are used when you're sending data between networks, such as over the internet, a WAN. And it uses the IP protocol. IP protocol. So IP addresses are made up of different types. There's two types of IP addresses. They can either be static, that means they are fixed, or they can be dynamic, they can change. Okay? Static means they're permanent, they keep the same, or dynamic means they can be given to you every time you log on. So if you think about this, it's a map of the internet. Oops. Every single device on the internet has an IP address on here. There are two types of IP addresses, however, two types that we looked at. Version 4 is made up of 4 groups of denary numbers between 0 and 255. Okay, so there's 32 bits in total, and you can have over 4 billion addresses. However, the problem is, if at the moment, these would all be used up. So IPv4 would have run out of addresses by now. So instead, we've got IP version 6. IP version 6 uses 128 bits, so it gives you over 340 trillion addresses. The main thing that I need you to understand is that IP version 6 gives you lots more addresses than version 4. And it's stored as, you can see at the top there, in hexadecimal. Okay, it's stored as 16 pairs of hexadecimal numbers. So it looks a lot longer and there's lots more addresses. IP version 6. It's enough addresses for all the devices on the planet. So, main differences on the screen. IP version 4, 4 groups of denary numbers separated by a dot. IP version 6, 16 pairs of hexadecimal numbers, and there are lots more addresses available with IP version 6. Fill in this section now, please, on IP addresses. Okay, checking your answer. So IP addresses are used by routers, we'll look at this more later on, to direct packets of data on a WAN or on the internet. And they can be static, fixed, or dynamic, changeable. And what are the differences between IP version 4 and 6? IP version 4 stores as 4 groups of denary numbers, 32 bits of binary, and there's over 4.2 billion addresses, and there's an example. IP version 6 stores as 32 hexadecimal digits, and there's enough addresses for all the devices in the world, and there's an example as well. Okay, let's continue. So, just to recap, remember, MAC addresses are used on LANs. They are unique, they cannot be changed, and they're used by switches. IP addresses are used on WANs or the internet, used by routers, and they can either be static or dynamic. They can change when you log on. And there's two types, IP version 4 and version 6. Okay, very last section, part 3. Okay, what is the difference between the internet and the World Wide Web? Well, remember, are they the same? No, they are not the same. Very simple thing to think about it is the internet is all of it, all the hardware that's used, all the networks, and then the World Wide Web is one feature that runs on the internet, as well as email, chat, instant messaging, peer-to-peer, all those things that run on top of the internet. And the basic things are the internet is all the devices, the network of networks that connects it together, and it uses the TCP/IP protocol. It's the hardware. The World Wide Web, however, is the websites, a collection of websites that are hosted or run on servers, web servers, on the internet. And they're accessed using the HTTP protocol. Remember the protocol that's used to access websites, HTTP. You can access the World Wide Web by using the internet. Complete this section now, please, very quickly. Okay, checking your answer. The internet, a network of networks that connects all the devices, uses TCP/IP. World Wide Web is a collection of websites that host on web servers and access through the HTTP protocol. Checking your answers, please. Improving. Ready to go on. Okay, you should have now completed the sheet with all your notes. Final task then today is to go to revision quiz 9 and complete the quiz online. Remember, same as before, check your answer, correct and try again if you have not got it right. Good luck and I'll see you in lesson.